equal r of r over r. I mean, r times r of r. So guys, I'm doing nothing but following Griffiths here. Once again. All right? So now work through this section, because if you don't work through this section, it will have no meaning for you. All right? But when you work through this section, you find out, you solve for capital R. So for example, you find that R equals U over R, and you find that dr equals something, and so on. You go through and you make all these substitutions, and you substitute this stuff into here. All right? And I'm going to get rid of what we have over here now. Everybody knows where we are.
Which are the big one or the little one?
Excuse me?
Yeah. But which are we?
Oh, where we are. Oh, very good. I was a little slow today. Very good. And so I'll tell you, so in modern, we were doing the Bohr model of the atom. So let's talk about what this effective potential means, because it has a lot of physical meaning. So we have this nice form. It looks like our original time independent Schrödinger equation.
And the book says that y of 0, 0 is actually 1 over the square root of 4 pi.
Oh, maybe that's where it comes from. Okay, so yeah, you would need that. Sorry, so times 1 over the square root of 4 pi. Okay, so check it out. Yeah, so I'm wrong. Let's correct this. So how would you normalize that?
So the 1 over the square root of 4 pi would come out, and then you just normalize.
Okay, so why don't you do this?
Let's not write that in the one that you just raised.
How would you normalize that?
Square integrate.
So you would have to do the integral, right? Yeah. And so when would you do the integral? How would the integral look like?
Psi star, psi dr.
Okay, but where is this wave function now? Does it have spherical parts?
No, it's just a function bar.
Well, no, it really did, right? We just put in the answer. So to normalize this thing,
We need to triple
you
integrate.
would need a triple integral. So you need the integral, triple integral.
Oh, so that's from the spherical number, so it's the square root of 1 over 4 pi.
Right, that's right. Yeah, from the spherical. It wasn't 1, it was 1 over the square, 1 over the square root of 4 pi. But the answer, we don't have the normalization yet. So the question is how do you normalize it?
So triple integrate the square
Okay,
How's
so
that?
it's going to be the integral. So let's do the radial.
from 0 to r.
Okay, let's
Zero
do
to
0 to a, 0 to 2 pi,
0 to pi.
0 to pi. Okay, a squared, sine squared stuff over r squared, then 1 over 4 pi. All right? Yeah? And then what's the differential element?
dr.
r squared dr
R squared dr
sine theta d theta
sine theta d theta
and then d phi.
d theta. All right?
To r
Oh,
squared.
and what does that all have to equal?
Has to equal 1.
That has to equal 1. Okay, so what happens to these r squareds?
Cancel.
They cancel. All right? So this comes out, this becomes 1 equals a squared. And then let's do it this way. This is going to be the integral from 0 to a of sine squared something dr. Right? And then I can take out the integral from 0 to 2 pi and the 0 to pi of sine theta d theta d phi. Okay, so what do you guys think this is? So what am I integrating over there?
That's what you say.
Okay,
It's going to be a 4 pi r squared.
it's going to
That's
not
the
r
solid-
squared.
That's your solid
That's
angle.
my solid angle right there. I'm integrating over all the angles,
So
but
it's
not for lengths.
4 pi.
So that's going to be 4 pi. So this is going to be 1 equals a squared. Oh, and I forgot
1 over 4
1
pi.
over 4 pi here. So 4 pi. So this is going to be a squared times this integral 0 to a of sine squared RDR, something in there. And there's going to be 1 over 4 pi. And then it's going to be a 4 pi. Alright, and so this looks like what we did before.
Wait, 4 pi, and then y is, what's the next 4 pi?
4 pi, those cancel.
And those cancel. Alright, and so we've done this integral a whole bunch of times for the 1D well. And so this becomes that a equals the square root of 2 over a. Right?
Yeah.
Everybody kind of agree?
Yeah, and then you multiply that by 1 over the square root of 4
Okay,
pi.
now let's bring it up here. And then you get psi n00 equals, a is 2 over the square root of 2 over a, then 1 over 4 pi, and sine n pi over ax over r. And what happens here, this
Would it be
becomes,
n pi r and n pi x?
yeah, n pi r. Alright, and this becomes,
What's the quantity inside the sine squared? We're just calling that blah, it's the anti-a over x. Anti-x over x.
say that again.
Yeah, that's n pi r.
Inside the sine squared.
So I'm leaving it, I'm not doing it. What I'm
Yeah,
doing,
Just call it blah, right?
what I'm doing is I'm gonna say, look, I recognize this is the exact same
Right.
calculus as I did for the 1D well. I'm skipping a lot of steps here.
Right.
But you did, now that you did it, it's not a problem, it comes out to be that. And so when you do this, this comes out to be, what?
1 over square root of 2a pi.
1 over the square root of 2a pi times sine n pi r over a over r. Is that the right answer?
Yes.
And that's the right answer. All right?
To be honest to what we've done today,
Yeah.
would you mind just bringing it all home and giving a quick recap? In general.
You do it. I've done for
Do
you.
the sphere, and when you get it down to r, you basically do the 1D
I'm
well.
talking about everything that we did.
So, Mike, everything we did is nothing new.
I know.
That's what I want you to hear.
No, I know.
That's the story. It's nothing new.
I know. It's just a lot of new steps, but the similar idea.
Is it new steps?
No, it's just different looking things.
It looks a little different, but is it really anything new?
No, when you go home and work it out, it makes sense.
Yeah.
You just gotta go home and work it out.
No, I mean, I think I laid it out in that way, like this is the same thing over and over again.
No, I know, but you know how to feel comfortable with it, to work with it for a while.
Yes. But I do think I laid it out. Okay.
I'm sure you did. When I go back in the video and I look at it, I go, oh, look.
I missed a good portion of it because the battery died, so.
Vessel functions. And I'll just tell you one story about vessel functions.
Are we going to be covering that material or no?
No, just read through it. So it's important. So what you should do is read through that section and look at it. It's nothing new. It's just a new answer, right, for the radial part. All right, and yeah. So when you do that, the answers look like this. So now you got psi to the n l ml of r theta and phi equals a to the nl, that's normalization constant, j to the l of beta to the nl of r over a. So these are the spherical Bessel functions. Times, what do you think the spherical part is?
The the same as it always is.
Same as it always, Y to the L.
Y to the L.